Okay, now that we have our two similar triangles, remember that these are dilations of each other. The shape stayed the same, but they became larger or smaller by a scale factor. Dilations create similar figures. That means our corresponding side lengths are proportional, which means we can write a proportional equation with our ratios. Remember, these ratios can set equal to each other because our triangles are dilations, which means our shapes are similar, meaning our corresponding side lengths are proportional. So we know that rise over run of our first triangle corresponds to the rise over the run of our second triangle. 1 corresponds to y minus 4, as 4 corresponds with x. Why can these ratios be set equal to each other? The triangles are dilations, hence similar, and have corresponding side lengths that are proportional. And all proportional means is that the ratios are equal. And when we have two equal ratios, which is a proportion, we can set up our equation and solve this with cross products. So we're going to solve the equation that we wrote above for y. And this is a really important problem, and there's going to be similar ones like that in your future. So 1/4 equals y minus 4 all over x. This proportion we solve with cross products, or we also call it cross multiplying. Because we're solving for y, I'm going to put my y term on the left. 4 times the quantity of y minus 4 is equal to 1 times x, which I'm going to write as x. Let's distribute this 4, and I get 4y minus 16 equals x. Now, if I add 16 to both sides, I'm going to just move up here now, I end up, that makes a 0 pair, 4y equals x plus 16. Now, to get y by itself, I'm going to divide each term by 4. Notice from the beginning, I could have undone the multiplying by 4 by dividing both sides by 4. Now, my final equation is y equals x divided by 4 is the same thing as 1/4 times x. And we want to see that m value, or the coefficient of x, so I do need you to write it as 1/4 times x. Plus 16 divided by 4, which is 4. This is the equation of our line in slope-intercept form. Where do you see the slope in the equation? Slope, again, is still the coefficient of x, the number being multiplied in front of x. Slope is the coefficient of x, and where do you see the y-intercept in your equation? Well, the y-intercept is at plus 4. What do we call numbers that are being added or subtracted at the end of the equation? Those are your constant term. Really good. Slope is the coefficient of x. I'm just going to put 1/4 there. Y-intercept, is the constant term. And remember, we're using equation vocabulary because this is an equation. And it's the same terms we used when we were looking at those linear representations and talking about the equations. Awesome. Let's turn the page. Number 6. Let's read the directions. Use the coordinate plane and instructions below to investigate the slope-intercept form y equals mx plus b. Remember, we're going to be looking at the same situation, except now, instead of having a slope of given a numerical slope, we're going to replace that with the variable m. Graph a line on the coordinate plane that goes through any point on the y-axis, represented by the y-intercept b, and has a slope of m. Label the rise and run on your graph with a right triangle, and redraw and label this triangle below the graph. So we want to go through the y-axis, anywhere on the y-axis, but let's make sure that we pick a y-intercept that's not the origin. You can pick a y-intercept that's below the origin if you want. I'm going to pick one that's above, and I'd like you to do the same for this example with me, please. So anywhere you want on the y-axis, let's go right here. And this is represented by the y-intercept b, so this is going to be 0, b. And now I need to draw a slope. Remember, your slope, which is m, we have the rise over the run, so we need to say that our denominator is 1 for our run. Let's make this a positive slope. You can make it as steep or as less steep, but don't make it 0. Let's make this have a positive slope. And then we need to draw a right triangle to show our slope, rise of m, and a run of 1. And then, of course, we're going to redraw our right triangle below. Remember, our right triangle we draw, we are always going to stop at that y-intercept, m and 1. We labeled the rise and run, and we also redrew. Does this line represent a proportional relationship? Does it, you guys? No, it doesn't. No, does not include the origin. I'm going to talk about including the origin because it's talking about the line, which means the graph. So now let's read part C, because this is where we need to read the instructions really carefully. Choose any point, x, y, on your graph and draw a right triangle that describes the rise and the run. Redraw and label this triangle below the graph. So we need to pick any point on our line x, y. I'm going to pick a point above, and I'd like you to as well. It doesn't matter where we pick, so I'm going to pick right up here. Remember, this is x, y, because if I drop a vertical line down, this is the x value. So if this was 20, that would be 20. And this is the y value of my coordinate. And I'm going to draw my right triangle. Make sure when you draw your right triangle, you only go down to the y-intercept. Do not go all the way down to the origin, because that's not a right triangle showing your line. The run of my right triangle, that's the easier one, so I'm going to do that first. This distance from here to here is the same as from the origin to x, which is x, so my run is x. Now I need to figure out this rise. Well, I know from the origin to my y value is y, and I know from my origin to my y-intercept, what's my y-intercept? Oh, that's just b. And I need to find from here to here. So I need to take that y amount and I need to chop off the b amount. Y minus b. Remember, it's y minus b because we still have a distance. If we did b minus y, we'd end up with a negative value. And we can't have a negative value for the length of our triangle. So let's take a look here. Here's my new right triangle. It's larger, but it's going to be a dilation, so the two figures are similar. The corresponding side lengths will be, you're right, proportional. So the run of my right triangle is x, and the rise is y minus b. Awesome. Great job. Write a proportional equation with your slope ratios. I think you guys have been doing a really good job with this so far. So remember, we start with our original slope and we set that equal to our new slope Remember, it's rise over run. I know because our x is labeled on top, we often want to put that x on top, but it's always change in y, we're changing x. Rise over run. Y minus b all over x. M corresponds with y minus b. 1 corresponds with x. I sometimes still need to check that I wrote my corresponding parts together because sometimes I will accidentally write my x values first. So now that we wrote our proportional equations, we can solve for y by solving our proportion. We solve proportions using cross products or cross multiplying. Since I'm solving for y, I'm going to write my y value first. Y minus b times 1 equals m times x. Make sure your m comes in front of your x because it's the coefficient. And now we need to get y by itself. Y is being subtracted by b, so I'm going to add b to both sides. When I do that, my final equation, are you ready, is y equals mx plus b. That's right, it's your favorite equation of a line, slope-intercept form. Where do you see the slope m in the equation? It's your coefficient of x. And where do you see your y-intercept b in the equation? It is your constant term. Great work. Let's turn the page to finish. How do you know if a relation is proportional based on an equation? How do you know if a relation is non-proportional based on an equation? What I'd like you to do is I'd like you to take some time to pause the video and finish 7, 8, 9, and 10 on your own. Finish 7, 8, 9, and 10 on your own. Pause the video to do that, and then we'll go over the answers. Please pause the video now. Okay, let's see how we did. A proportional equation is going to be in the form y equals mx. I put a plus 0 as kind of a ghost plus 0 because there's multiplication only, but sometimes you see a constant term of 0, and I don't want you to think that it's non-proportional just because there's a plus 0 there. So the simplified form is always y equals mx. Non-proportional, y equals mx plus b, the simplified form, there's multiplication and addition. B does not equal 0. How are the equations y equals mx and y equals mx plus b related to each other? Remember that they're translations of one another, b units vertically. If we went back to our third page, we saw that our original equation, our proportional equation, and our non-proportional equation was just a vertical translation, a slide or a glide. And it's b units vertically because b represents our y-intercept. We graphed y equals 4x on our coordinate plane. Remember, that's y equals 4x plus 0. So we wanted to make sure that we had a y-intercept of 0, and then we moved slope amount, which is 4 over 1. So up 4, right 1, up 4, right 1. Also, because 4 over 1 is equal to negative 4 over negative 1, we could also go down 4, left 1, down 4, left 1. And we looked at that in our treasure hunt activity. So then, if we want an equation of a line shifted up 5 units from y equals 4x plus 0, we're not changing the slope or the steepness of our line, we're just shifting or gliding, what's the word? Translating our line up 5, making our new y-intercept 5, our constant term in our equation. So when I go to graph that, I always start at my y-intercept. Just like before with it proportional, we started at 0 because 0 was our y-intercept. So I started at my y-intercept of 5, I went up 4, right 1, and I could also go down 4, left 1 because of the previously explained reasons. How do the graphs relate? Y equals 4x plus 5 is a translation of y equals 4x, up 5 units. And don't forget, they're increasing lines, which means they're going up from left to right. Similarly, if we take a look at the next one, y equals negative 3x minus 7, make sure your slopes are decreasing. You have a slope of negative 3. That means we have negative 3 over 1, which is the same thing as 3 over negative 1 for rise over run. and y equals negative 3x minus 7 is a vertical translation